Good morning, guys. I am Karthi. I am working as an assistant professor in the Department of Mechatronics at SNS College of Technology. Today, I am going to present an introduction to Hadoop, which is an open source framework used for distributed storage and processing of large data sets. So, in today's data driven world, organizations generate massive amounts of data every second. So, traditional systems cannot handle such large scale data efficiently. So Hadoop was developed to solve this problem by enabling storage and processing across multiple machines. So what exactly is Hadoop? So Hadoop is an open source framework designed to store and process huge volumes of data across clusters of computer. Instead of relying on a single powerful system, uh, Hadoop distributes data across many systems, making it highly scalable. It can handle structured, semi-structured and unstructured data. One of the key advantages is that it can scale from a single server to thousands of machines, making it ideal for big data application. So moving to the Hadoop ecosystem. The Hadoop ecosystem is just not a single tool. It is a complete ecosystem of components like which the key components include HDFS for storage, MapReduce for processing, and YARN for resource management. In addition, there are supporting tools like Hive, Whale, HBase, and Spark, which helps in data analysis, querying, and real-time processing. So this ecosystem makes Hadoop more powerful and flexible for different types of applications. Followed by this Hadoop components, let's look at the two core components in detail. First is HDFS, which stands for Hadoop Distributed File System. So it is responsible for storing data across multiple machines. It provides high throughput and fault tolerance, meaning even if one system fails, data is not lost. So it comprises of four major components such as distributed storage, high throughput, fault tolerance, and scalability. And secondly is the MapReduce, which is the processing framework. It divides tasks into smaller parts and processes them in parallel across multiple nodes. The processing happens in two phases. The one is map phase, processing the input, and a reducing phase, which will aggregate the result. So this approaches allows Hadoop to process massive data sets efficiently. So followed by the HDFS architecture. Now let's understand how HDFS works. In HDFS, files are divided into smaller blocks and stored across different machines in a cluster. So each block is replicated usually 3 times to ensure the reliability. This is called the replication factor. If one system fails, Hadoop automatically retrieves data from another copy, ensuring the fault tolerance. So HDF is optimized for high throughput, which means it is best suited for the batch processing rather than the real-time processing. So the major key features in the architecture is the distributed storage that in which the files will split into blocks, and secondly is the block replication. Default replication factor will be 3. The third one will be fault tolerance and highly efficiency and highly throughput. So followed by the MapReduce workflow. Let's look at the workflow of MapReduce. The process starts with input splitting when large data is divided into smaller chunks. Then comes the map phase, which each chunk is processed and converted into key value pairs. Next is shuffle and sort, where intermediate data is transferred and organized. Finally, the reduced phase aggregates the result and produces the final output, which is stored in the system. This step-by-step distributed processing is what makes Hadoop efficient for large-scale analytics. So the major key advantages of Hadoop offers cost effective because it is uses commodity hardware. It is highly scalable and can handle growing data. It provides flexible processing for different data types. It supports fast processing, usually parallel execution. It ensures fault tolerance to data replication. It reduces network traffic by processing data locally. These benefits make Hadoop popular choice for big data application. And this is the Hadoop mind map where the Hadoop is at the center, surrounded by its core components like HDFS, MapReduce, and the ecosystem like YARN, Spark, HBase like that. And key features such as scalability and fault tolerance and high throughput, and its benefits like cost effectiveness and flexibility. It also highlights the use cases like big data analytics, ETL process, and data warehousing. So in a recap, we have learned and discussed what Hadoop is, explored its ecosystem, and understand its core components like HDFS and MapReduce, and learned about HDFS architecture and MapReduce workflow, and finally looked at its advantages. So to conclude, Hadoop is a powerful framework for handling big data. It provides scalable storage and processing, fault tolerance architecture, and cost effective solution using distributed computing. With the growing importance of data analytics, Hadoop plays a crucial role in the modern data driven industries. So thank you. Today we have discussed about the Hadoop. In next class we can discuss about the architecture. Thank you.